Now I want to make an introduction to HuperFun. It's a language and environment for geometric modeling based on the function representation. I'll just introduce implicit curves, surfaces and solids. We'll explain the basic of a geometric modeling language called HuperFun, and we'll give an example of a HuperFun model. Let me remind you of a few basic concepts. Any geometric shape consists of points. How we can decide which point belongs to the shape, which not? Imagine we have such a black box where we put a point and the box gives us one of two possible answers. Yes, this point belongs to the shape, or no, this point is out of the shape. This box is called a point membership rule. It corresponds to the so-called implicit form of geometric models. Let's consider how we can define such a rule for two-dimensional and three-dimensional shapes. If we take some real continuous function of point coordinates x and y on a two-dimensional plane, and then select all the points on the plane where this function has zero value, the collection of points we found is called an implicit curve or isocontour, and it's defined by equation f equals 0, where f is our real continuous function. If we select all points where the same function is positive or equal to 0, then these points make a two-dimensional area, a piece of plane, or a two-dimensional solid, or a planar patch, defined by the inequality f greater or equal 0, and the implicit curve will be its boundary. This concept is much easier to understand with a practical example. With the simple function shown here, the equation f equals 0 defines a circle as an implicit curve. Note that the function is written in such a way that it has positive values inside the circle and negative outside. If we change the equation into an equality, we define the circle and all points inside. This object is called a disk, which is a two-dimensional area or a two-dimensional solid. Let us make a step one-dimensional higher and consider functions of point coordinates in three-dimensional space. The equation f equals 0 defines an implicit surface, and the inequality f greater or equal 0 defines a three-dimensional solid with the implicit surface as its boundary. As an example, we can see here a spherical surface and solid ball. Symmetrical to the two-dimensional case, the equation defines an implicit surface called a sphere, and the inequality defines the sphere and all the points inside, making an object called a solid ball, or simply a ball. Now let's take a look at what HuperFun is. HuperFun is a minimalist language, a kind of simplified C programming language. Its purpose is modeling implicit curves, surfaces and solids. The name HuperFun originates from hyperdimensional functions, because it works with functions of 1, 2, 3 and multiple variables. The expressions for defining functions can be typed directly, but for the higher level models, a library of primitives and operations is provided. It helps making models in Lego style. Built-in structured programming constructs, such as loops and if statements, allow for more complex procedural definitions. HuperFun is not case-sensitive. Small and capital letters are the same. A program in HuperFun serves as a black box we mentioned at the beginning. It inputs point coordinates and calculates the function value at the given point. The program in HuperFun consists of one or few objects. An object has a name, model here, input array X with point coordinates, input array A with shape parameters, like the radius of the shape. Even if you do not use parameters, A1 has to be written. The body of the object inside curly brackets consists of statements, each finishing by the semicolon. There are 4 types of statements in HuperFun, each ending with semicolon. Assignment statement for a variable, assignment statement for an array, conditional statement, and iterative statement. At the top you can see examples of the assignment statement for a variable or for an array element. Standard math functions as square root and expressions are allowed at the right-hand side of the assignment, where this statement means power 2. Note that there are no types in HuperFun except a linear array, which has to be declared at the top before any other statements. See array pz, which declares an array pz of 4 elements. Below, an assignment statement for an array is shown. The conditional if-then-else statement is pretty standard but has to be closed by AND if. The iterative statement while loop checks only condition in the brackets I less than 10, but the rest of the loop organization has to be in the program, such as index I, initialization, and increment. The loop finished by AND loop. This is a HuperFun model of a torus given by its analytical formula. The following agreements are used. x1 is x coordinate, x2 is y coordinate, x3 is z coordinate. The statements like this are used to avoid multiple power function calculation. The interactive system HuperFun for Windows can be used for modeling. It allows for specifying a function of point coordinates in HuperFun, make triangular mesh on the surface, drawing the mesh, see the rendered torus, rotating and zooming, and changing rendering parameters, such as mesh quality, color, and so on. The main source of information is the HuperFun website and especially its pages with the HuperFun language specification, the frep library description, students' works in the gallery, and the tutorial on HuperFun basics.